Welcome to Lockheed Martin Space Makers, the podcast that takes you out of this world and an inside look at some of our most challenging and innovative missions. This week we are covering NASA's Artemis 1 mission, which is launching the design and built Lockheed Martin spaceship to the moon. Today we have special guests to talk about the AstroRad vest, which is designed to protect astronauts from deep space radiation. Thank you for joining us today, and do you mind introducing yourselves?
Yeah, I'm Jordan Huri. I'm the lead scientist for space exploration at STEMRAD.
Hello, my name is Shirit Schwartz, and I'm the AstroRad product director.
So what exactly is this AstroRad vest?
So as you said, the AstroRad vest is a personal wearable protecting vest that protects astronauts from space radiation, and it was mainly designed to protect from charged particles, solar particles, that are being spread during solar storms.
That's great. So can you share a little bit more about how this vest was developed, and then how does it work? How does it stop those solar particles?
So following NASA's plan to send astronauts further deep into the space and for longer period of time, the radiation issue was needed to be addressed. So they reached out to Lockheed Martin for a solution, and they contact STEMRAD, since STEMRAD is specializing in developing personal protective wearable solutions that protects against radiation. We have the 360 gamma belt, which protects first responders from gamma radiation. And we actually adapted the principle used in that solution into the vest. And the principle we are using is a selective shielding principle, meaning that we add more mass over the more sensitive organs. And here you can see the shielding core. This is the shoulder panel, and it's made of thousands of hexagons put together, assembled together, and providing us a solid structure that prevents the radiation, harmful radiation, to penetrate the body. But because it's divided to so many segments, it is a flexible structure for the comfort of the user.
Yeah, they can move around.
They can move around it, yeah.
Wow, that's amazing.
And the material that is being used here is the polyethylene, and we're using a high-density polyethylene since it is rich in hydrogen. And hydrogen is the best element to absorb the energy from charged particles.
Wow. So, Artemis 2 will be sending NASA astronauts to the moon, and they're going to be encountering deep space radiation that's different than what astronauts experience in low Earth orbit at the International Space Station. So can you talk about the difference between radiation you experience in deep space versus what you experience in low Earth orbit?
Yeah, so the major difference between the radiation that astronauts will see in deep space and low Earth orbit is basically just the energy and the intensity of the radiation. Okay. In low Earth orbit, they are still within the protection of the Earth's magnetic field. And that magnetic field mainly stops all the low energy radiation that is coming in, and that's what makes up most of the radiation. Also, the low energy radiation is the most harmful radiation because it very easily deposits harmful energy within the human body. So once you leave the protective bubble of Earth's magnetic field, that type of radiation is much more prevalent. And that's why we want to have a solution like the AstroRad vest when NASA sends their astronauts to deep space.
So on Artemis 1, Orion is launching. The AstroRad vest is being flown on Orion, performing an experiment. Can you share a little bit more about that?
Yeah, so this experiment is called the MARE experiment. That stands for Matryoshka AstroRad Radiation Experiment. So the Matryoshkas are the phantoms. And phantoms are basically human body models or mannequins. And these have thousands of radiation detectors throughout the body. And in addition, these phantoms are human tissue equivalent. So the material that they're made of basically mimics the density of bone, the lungs, the breasts, and other tissues just so that the radiation, when it passes through the phantoms, will interact with the object in the same way that it interacts with the human body. So basically, the phantoms will allow us to determine exactly what the type of, what the dose in a human body will look like when astronauts travel to deep space. So during this experiment, there will be two of them, one named Helga and one named Zohar. And Helga will not be wearing the AstroRad vest, and Zohar will be wearing the vest. So when they come back to Earth after the Artemis 1 mission, we'll be able to compare the results from all those thousands of radiation detectors and find out exactly how effective the AstroRad vest is, and we can determine what improvements need to be made and optimize the protection for our astronauts.
Excellent. And this vest was developed with a lot of international cooperation. Can you talk to that a little bit?
Yeah. So first of all, we are very grateful for this collaboration with Lockheed Martin, DLR, and the Israeli Space Agency. And each of one contributed to this experiment, this MAR experiment. Lockheed Martin were handling all the logistic aspect of sending the AstroRad out into space. They developed the standard for the vest. For example, making sure that all the material that is used in the vest complies with NASA's regulation for outgassing and flammability. And of course, they provided their expertise in deep space in radiation environment. STEMRAD led the design of the vest using the selective shielding principle we were mentioning before, and the Israeli Space Agency provided the vest for this MAR experiment. The DLR team, they provided the two phantoms, and they will lead the data collecting from the detectors once they come back, the phantoms come back to Earth.
Well, I know Lockheed Martin and NASA is appreciative of your work of developing this vest, and we look forward to looking at the results that come back from Artemis 1 and when this vest goes to protect our astronauts on the Artemis 2 mission. Thank you very much for joining us today on Space Makers.
Thank you.
Hey, and we're back with Space Makers. I'm with Stu McClung, who's a NASA Orion engineer. Thank you for joining us today.
Thanks for having me.
We are 2 days away from the launch. We're all very excited as we prepare to see Artemis 1 launch the Lockheed Martin designed and built Orion spaceship to the moon. Can you share a little bit about the Artemis 1 mission objectives?
Glad to. Yeah, I share your excitement. I've been working on Orion with your team for a number of years, right? I think every one of us is, we're ready to go. We've, leading up to today, right? We've assembled, we've tested here at the Cape, labs across the country. Everybody's done their due diligence. So we're about to prove to ourselves that our work is as rigorous and good as we think it is. That's kind of the way I like to think about it, right? See an exciting launch come up, fairing separation, is one of my personal interests, fairing separation. We'll get a good system checkout. ICPS will give us a good TLI burn, and then off to the moon we go. So.
That's awesome. Now, Artemis 1, it's taken quite a bit to get here, and can you share some of the milestones that it's taken for us to get Artemis 1 on the launching pad?
Well, certainly. I mean, yeah, between the work we've done in the ITL at Denver, or down the road here in the ONC with assembly, we've done vehicle power on testing and proof testing of all the propulsion and the ECLS systems. Right, we have done at every system level. We've checked this vehicle out, and I like to think of it as building blocks. We've brought all those building blocks together, and she's sitting out there on the launch pad right now, ready to go.
Awesome.
Right, and so that's got us to this point in time, and now we've got milestones coming ahead of us as we execute the mission.
Yeah, speaking of that, obviously the launch is one of the most visually exciting moments, but Orion has a 40-day mission ahead of itself. can you share some of the things that NASA's excited about? Maybe some of the things that you're personally excited about the Artemis 1 mission?
Oh, certainly, yeah. So we've got north of 100 test objectives on this flight, and so there'll be multiple events and multiple tests along the way. Like I said, the ICPS will send us on the way, get to the moon, and do a nice low, close flyby of the lunar surface. Like I said, every system gets tested. We've got 11, I think it's 11, maybe it's 13. We've got a bunch of cameras on our vehicle. There's 4, one on the end of each of the solar arrays. And so, and we have that for our vehicle data needs. I also think we'll probably get a really good selfie from the vehicle looking back. I think Orion's going to give the world a really good selfie when we do a low flyby. You have the major burn events, then we go into the distant retrograde orbit, and when we come back out of the retrograde orbit, return home. Personally, I'm looking forward to entry day. I'll be in the mission evaluation room with the team when we're doing re-entry. The heat shield, testing the heat shield is one of our key test objectives to demonstrate its readiness for putting crew on Artemis 2. And then all the landing systems and parachutes that earlier in my time in Orion I got to personally work on. So I'm really looking forward to watching those systems operate, and we'll see how they perform.
And speaking of the heat shield, when the objects are entering the Earth's atmosphere from low Earth orbit, they're coming at a much lower velocity than maybe what you're coming from the moon. I don't know if you want to speak to that just a little bit of the amount of velocity that you're encountering.
Just a little bit, yeah. When you come back back to deep space, you're roughly 25,000 miles per hour. So you're moving.
That's fast.
Yeah. It's fast, right? And so you start the reentry process, and I always like to use the term surfing, which is not the right technical term, but it's how I visualize it. You decelerate by trading that speed for heat. And you come down through the atmosphere, and the vehicle is hitting the denser atmosphere. The heat shield is seeing extreme temperatures, and the vehicle is decelerating in that process. And the heat shield will see temperatures, parts of it in the range up to say 4,000 degrees Fahrenheit.
Wow.
Right? Lava flows at 2,100, so you are seriously hot. And so we've tested this in the lab on small test articles, but one of the key objectives for the mission is 16-foot diameter heat shield, and how does that heat energy across the acreage of that heat shield, how does it behave? Do we have it modeled correctly?
Right.
Right, and so that we know that, again, on Artemis 2, we're going to have astronauts in there, we're going to have crew, and that's our job, is to send them out and bring them back home. And this is a key objective, to make sure that when we fly them, that we're going to do it properly.
And that segues nicely into my next question. You mentioned Artemis 2, astronauts are going to be flying on Orion to the moon. Can you talk about what's next after this launch of Artemis 1?
So after Artemis 1, we'll bring the vehicle back. We're actually sharing some pieces of avionics out of Artemis 1 to the Artemis 2 Orion.
Okay.
We'll also be looking at all of our flight data, and if we learn something from this flight test that says we need to make an adjustment,
right,
we'd have that discussion and work that in.
Right.
Otherwise, right, Artemis 2 is already being assembled and tested over in the down the road in the IOZ, so that's going well. We'll bring crew on, bring on the rest of the crew-related support equipment, put that in the vehicle. We'll do a rendezvous demonstration on Artemis 2 and set ourselves up for Artemis 3 when Orion will go and rendezvous and dock with the lander system. And then we'll start taking crew down to the surface.
Yeah, that's awesome. Well, Stu, on behalf of myself and everyone at Lockheed Martin Space Makers, we thank you for taking the time today with us and for all that you're doing on Orion.
Well, thank you. Thanks for y'all's support.
Thank you for joining Lockheed Martin Space Makers today. Follow along as we continue the coverage of NASA's Artemis 1 mission. You can watch these interviews on YouTube or wherever podcasts are found at Lockheed Martin Space Makers.